All right, one more from chapter 17. We'll be almost done the chapter after this. Loose ends on Wednesday. That's a lithium aluminum hydride here. It's more reactive than NaBH4. And you know, I'm all about reviewing as we go. Let's do an NaBH4 review. Chapter 6, we saw, wow. We saw RHGOAC. You reacted with NaBH4. And it got rid of the mercury. Remember that? Chapter 6, demercuration. And if you were doing it in the lab, it's actually kind of a pretty reaction, but a little on the dangerous side because you're making mercury metal. What's that look like? Silver puddle in the bottom of your vessel. How do you know it's at the bottom? Well, the density of, silver. It's silver colored. That's where mercury gets its name. Hg, hydroargentium, argentium, French, Latin origins for silver. Hydro for water. Yes, mercury flows like water and it looks like silver. Good name. Some of those names I really like. Some of them are just a pain in your butt. Okay. And don't worry about what happens to the boron there. Chapter 6, we saw that. Chapter 16, we saw NaBH4 again. We had aldehyde or ketone. Wow. I don't know what to do there. We're looking at the screen still, I hope. I hope our video's still running. I'm going to minimize that. This is, wow. How many bad spots can we have? Aldkete. One of those R's would be a H if it was an aldehyde. And use NaBH4 followed by HCl. Okay, didn't like that. And you get your R, your C, and your O. And you get your new new H here, sorry. And your new other H over here. And you get alcohol. Chapter 17, I'm going to put it here for a good point. The whole point that's here is this reason it doesn't react. No reaction. So we need a more reactive chemical for chapter 17. And this brings to a close our NaBH4 review and motivates us why we learned about lithium aluminum hydride being more reactive than NaBH4. The chemistry looks the same. You generate H minus first. That's where hydride, why it has the name hydride in it, because the behavior is that of a hydride nucleophile. In this case, the first hydride nucleophile is going to be consumed in an acid-base reaction. So it's acting like hydride the base. A little on the dangerous side. Make sure things don't get too hot. And now we're ready to start the reduction part of the mechanism. And you're going to need another H minus here, which already showed me how you made the first one. Yeah, we're working on mole number 2 of H minus here. And this guy's going to go and hook up with the aluminum. I like the name of this molecule. You got to bear with me. I love names. If it was carbon with 4 H's, like neutral carbon with 4 H's, what's the name? Methane. Now it's aluminum that is analogous to methane, and it sounds like a guy's name with a French accent. It's Alain. Yeah, it's Alan in French. Okay, Alain. It's not even spelled that way in French. Trust me. I just like the name. I don't know it. And then, yeah, you're going to get an H. Hey, one of your reductions is done, isn't it? You got a CH where you used to have a CO. And that has the aluminum on it, Alain. Look at that. It fit in my box here. My bad spot on the screen is now being used. I laugh at you. Okay, I'm sorry. Okay, so we got a new H on it. Oh, yes. There's some quizzical expressions out there because that O minus disappeared for no reason. There we go. My box is changing size. There you go. We're not there yet, are we? Hey, aluminum's got a minus charge again. And I hope you do know that there's 2 new H's on this position that weren't there before, and you've only done one of them. You see that? So I need another H minus, and I need another carbonyl. Okay, do you see that's going to make another H minus? I have an O minus that can leave, and I have a lone pair here, and I'll do it in another color because this is second. That's just elimination, by the way. Do you remember what elimination makes? I should do it in blue. Pi. That's exactly right. Elimination makes pi. The blue part is the elimination part. And now we're into chapter 16. Because what functional group do you have now? That's an ald. Yeah, aldehyde. And that's going to react with H minus number 2, which I forgot to draw. H minus was made as well. And that's just, notice I have not used HCl yet, and I can't use it until the very end. You are ready. You are ready. Tell me how to get there. HCl, right? HCl. Acid base. And done. And if you're big on side products, I want to point out that when you made the other side product here, it is the conjugate base of this second side product up here, isn't it? And if you want to show it being made and not make too big of a mess, I suppose you can do this. It got HCl in the second step too, didn't it? And it's not going to show up very well. There. I think we're done. And the thing is, you got a primary alcohol. That's critical. So if you need to make a primary alcohol from a carboxylic acid, what are your chemicals? Lithium aluminum hydride followed by HCl will give you a primary alcohol. 2 new H's on there. And that's good news.
So what happens if we use H2?
Oh yeah, here's it. Might as well put it in our review here. Also, chapter 17. Great question. Answered very shortly here. Even if you use H2PT in a ton of pressure, no reaction. That's how resistant carboxylic acids are to reduction. So you're down to only one candidate for any reduction of a carboxylic acid. Lithium aluminum hydride, HCl. Nothing else going to work for you. And that's good to know. And it's good to go.